So hello viewers, we are going to learn indices today. So when we say indices, we are referring to powers. That is, indices means powers. For example, if you have 2 raised power 5, so this 5 is called power or index. So now the word index is derived from index. When it is singular, we call it index. When they are plural, we call them indices. So now these indices there are certain laws that are followed while solving indices. I think this power are up to 10. So now let's learn those powers before we can be able to move forward. So now I'm going to mention each and every power before we pick example that we're going to solve. Let's see laws of indices. So this laws of indices, the first one is saying if you have a raised power x times a raised power y is the same thing as a raised power x plus y, which means whenever you have bases that are the same, as we illustrated here, a here, which means the bases are the same, but you have different powers. Therefore, you're going to pick one of the base and then add the powers, whether the powers are the same or not. So now the second law say that if you have a raised power x and then divided by a raised power y is the same thing as this a raised power x minus y. Whenever you have the bases that are the same, so you are going to subtract the second power from the first power, that is to say x minus y. This is the second law. So for the third law, when you have a raised power x times b raised power x is the same thing as ab raised all of them raised to the power of x, which means when you have different base but you have the same power, therefore you are going to multiply the base and then you pick one of the power, you factor the power out. So the fourth one is this: if you have a raised power x divided by b raised power x is the same thing as a over b, all of them raised power x, which means when you have different bases but the same power, therefore you are going to divide the bases as they are here and then you are going to factor out the power. The fifth law says that if you have a raised power minus 1 is the same thing as inverse of a, that is 1 all over a. This minus tell us that it is inverse, that is inverse of the base given. So then the sixth law says if you have a raised power minus x is the same thing as 1 all over a raised power x. So now this minus normally is inverse, so we are taking this power into on this, and then this minus turn to be the inverse. Then the seventh law says that if you have a raised power 1 all over 2, which means if you have any number raised to the power of half, this is the same thing as square root of a. So the eighth law says that if you have a raised power x all over y, this is the same thing as white root of a raised power x, or white roots of a all of them raised power x. So the ninth law says that if you have a raised power 0 is the same thing as 1, which means any number raised power 0, whenever you see any number, no matter how big or small the number is, provided that it is raised power 0, then it's said to be 1. So the 10th law, which is the last law, if you have a raised power x, open and close bracket, y here, all of them are powers. So this is the same thing as a raised power xy, which means you are going to multiply the x and y together whenever you have something of this nature. So therefore, these are the laws of the indices. So now let's quickly see the application of those laws. So let's learn the application of these laws when in simplification. So for examples, let's simplify the following. A. Let's pick example A. That is, if you have 9 a raised power minus 5 times, let's say 4 a raised power 6, and then b, if you have, let's say 22 n raised power 7 divided by 2n raised power 3. Then let's pick another one, which is C. If you have let's say minus c raised power 2 times c raised power 4 divided by all minus c raised power 5. So now let's solve these ones and see how the solutions are. Solution. Let's solve them. Let's start by number A, which says we have 9a raised power minus 5 times 4a raised power 6. So now when you look at this one here, you are going to separate because this is times, there is times here and there is times here, therefore you're going to separate the number and the unknown here. So we are going to separate them. So this is the same thing as to say 9 times a raised power minus 5, then times 4, also times a raised power 6, in between here there is multiplication, here also there is multiplication. So now then we are going to arrange it. This is number, that is 9 and 4, they are like times. Then this is a and a, they are like times. Therefore we are going to make rearrangement here. This is the same thing as 9 times 4, we fix this 4 here, and then we have a raised power minus, times here, have a raised power minus 5 here, then times this a, that is a raised power 6. So now when you can be here 9 times 4, you can be able to multiply them since they are number. Therefore 9 times 4 is the same thing as 9 times 4 is the same thing as 36. And then here we have a here, we have a here. Based on the first law here, when you have a raised power x and the a raised power y, therefore we are going to add the powers. Therefore we are going to do the same here. So here we have a raised power minus 5 then plus 6. So here this is 36. When we minus 5 plus 6 is the same thing as 1, which means we have a raised power 1 here. A raised power 1 is the same thing as a. This will be our final answer for the first question, for the first example. So B, the second one says I'll go a little bit faster. So for this one we have here 22 n raised power 7 divided by 2 n raised power 3. So here this is the same thing as in this case we are going to make this division. We are going to take this one down here. This is the same thing as 22 times n raised power 7 divided by here we have 2 times n raised power 3. So as you can see here, this n here 1, n here 11. So here this is the same thing as here we have 11 already times here n, they are the same thing. N here is an n here, but the powers are different. Therefore, we are going to use this second law, which says if you have a raised power x divided by a raised power 1, we are going to subtract the power. So therefore here we have the bases are the same, the powers are different. Therefore, we're going to subtract the powers. This is the same thing as n raised power 7 minus 3, which is the same thing as here 11 n. 7 minus 3 is the same thing as 4. 11 n raised power 4, which is our final solution here. So let's go for the third one. That is for the third one here. So that is which is c, which says if you have minus c here square times c raised power 4 divided by minus c raised power 5. So from here we can be able to factor c raised power 2 here from this c raised power 5 so that it cancel this one. So here we have minus c raised power 2 times c raised power 4 here. In the denominator here we can factor 2 as minus c raised power 2, which is the same thing as minus c raised power 2, then times the remaining here we have c raised power 3, that is minus c raised power 3 here. As you can see, this one can cancel this one here. Cool. So this is the same thing as what remains here is c raised power 4 divided by minus c raised power 3. So we can be able to factor the negative here, which is the same thing as to see c raised power 4 divided by minus 1, also times c here raised power 3. So here we have c here, the denominator here, the bases are the same, the power we are going to subtract the power. This is the same thing as this minus 1 is going to be here minus 1, then times here to say c raised power 4 minus 3. So finally when we subtract this one is going to give us minus 1 here. When we subtract 3 from 4, we are going to have c raised power 1. So when we multiply minus 1 by this one, we are going to get minus c as our final answer. So here is exercise for us to try. So now when you try, you can be able to solve it on a paper. Then you snap it and post it in the comment box. So if you encounter any difficulty, you can contact, you can chat with me there, and there you can comment your problem there, and I will be there for you.